Let's start with this view. This stream is not sponsored by Schwab Zero. Very fizzy, the most fizzy drink I know. Alright, peeps. Chat is working, everything is working. Welcome to the stream. We have STM32 fan t-shirt, although I never used an STM32 so far, knowingly. Not that I avoided it. It just didn't happen yet. Schnitt schnaps. No. Hello Dishipu. Hello ITT. Hope you're still looking. We have also Twitch showing up. Twitch is coming. And since last we can recap last stream, what happened last stream. That was really interesting. Maybe we can even show made drink. What kind of drink is it? Hey Sonic. Oh yeah, let's monitor the temperatures. So you know what I did? This is like the roof here, and it's not insulated at all. So during the day it's getting above. During the night it's like going down to 22 degrees, 25 maybe. Now these days it was like more like 24, 25, and during the day it rises to 32, more or less. So what I did like an hour ago, I went outside, took the water hose. Yeah, it's hot. Yeah, I took the water hose and sprayed the whole house from outside to create like this a fridge-like situation due to the evaporation. The temperature, I measured it, of the roof instantly lowered by 5 degrees C. So it was even cooler, I believe, than the water I sprayed it with. That was instantly. Of course, there is like a lot of mass, so we have like a stored heat in mass, but it dropped like to 27 degree from 22 or something. Yeah? And now we have here, let's monitor it. Oh, okay. It's 31 degrees C again. Here 32, here's 33. Oh, what? Why is it so hot again? Damn. Okay, let me check outside. Because I just took a shower, a cold shower. The roof is red. Okay, outside it's 27, so I should take the fan. Yeah, it's the lighting, of course, and my PC, who like now streaming, is compressing everything. Wait a minute. Let me unplug the fan, plug it into this thing, and the extension cord. Maybe I can get some air from outside over here. Okay. I hope that will direct a little bit of. Let's open that as well. Maybe I will open. The cellar door. Okay, I opened the cellar door to hope that the warm air would drag upwards and pull in some fresh air from outside. Fresh air, it's 27 degrees. fresh. Okay, now let's measure it again. Okay, what do we get there? 30 degrees, that's cool. Okay, 31, 32, here's 33. Hey Kai! Worked with DS pics before, what is that? Painted with the recently tilted special white paint. Apparently it's actually cools below ambient. Sprinkle it with glitter, yeah. MCUs from Microchip. DS pics. Is it... What is... What is that? Digital signal processor pics. Do you have like a component number? (32) 33A. What is this? Digital signal controls. Okay, let's share the desktop here. We don't need the camera view. Oop. Real-time control with precision and performance. Double precision FPU? We might. Tommy, I'm not sure. We need to do a lot of software beforehand. And hello, by the way. Hey, Roddy. Welcome to Berlin. Complex to work with? How do they work? Okay, so Infinite Coder. I'm currently, and I'm distracted now with this DSP FPUs, MCUs, but today our goal would be where I left off last time is optimizing the speed and lowering the idle time of the SPI. Now, next step would be to send bigger chunks over SPI where we combine multiple packets. And then we will start, we will try the CH32417 with USB 3 if we can get higher speeds. If we can get higher speeds with this one, we will hook it up to the parallel port and try communicating parallel. Yeah, that would be that, but I'm not sure. MCC MP Lab X, and lets you configure the peripherals really easily. Oh, okay. A lot of Terran. You did a lot of coding. What did you do with that one? No, it's not. Oh, it might be. Yes, it's H417. Sorry. What did you do with the digital pro? Just drive. Just don't speed, then you won't be caught. Pop. 40 ADCs. Wait, 40 mega samples ADCs. That's like in the range of oscilloscopes, converters, op amps. 78 picosecond PWMs. Oh, are they so expensive? 512. Explore. BGA. But there is also flat pack. Ah, okay. Okay. All right. Yeah, nice. A nice MCU. Unboxing my IP address. Oh no. Oh no. Oh no. Oh. Now you saw all my private windows. Oh. What did I show? Oh no, my private chats. Okay. Anyways, it's nothing kinky there. Where are we? You didn't see anything. You promised. Okay. Yeah, desktop. Just drop everything. That's smart. Yeah, let's do that. Minimize all windows. Okay, I'm almost done cleaning my SD card, because if we use R, we will do the packet size, change the packet size. Hey, I'm a Boyd. So last time we managed to send packets level 4. That's I can't even show that. Maybe. Let me check. Most resilient. Yeah, I found Atmel also very sturdy in a very hostile electric in a hostile generator environment. So it was like a combustion motor that was driving a generator, and there were like voltage spikes and everything, and we used a classic Atmel and it worked fine. Everything else broke down, but the Atmel controller, I think we didn't break a single one. It was like we burned even a hole into the PCB because there was like some stray current, reverse current or whatever. But the Atma stayed fine. So that was that. Oh, before I forget, I have to do something here. Yeah, I wanted to show. What we did last time. Maybe I have a screen recording of that. Oh yes, I have a screen recording. Okay, so this is what we did last time. This is like the um, 2 microseconds transmission of what is 8 bytes, and there is like this gap, and we lowered the idle time. Now what we want is to transfer bigger chunks. So let's do that. But what I'm curious about, if we debug the stuff, I saw packets, USB packets that are not the right size. Like they're not all 512 bytes. And I'm wondering if the remaining time, basically all the code in between. The Shipu, you haven't been there, or have you been there, like till the end last time? So what I can show you basically, you watched it later? Yeah, you watched it probably while doing something else. But you can see here, um, just avoiding a call that in the end does nothing else than setting the flags, that saved significant like amount of time. We shaved down like microsecond by microsecond by removing like the function calls, and you can imagine. So what's happening in between those packets is whatever is in here and in this function. So basically this is here. This is DMA enable. That starts the... That didn't work. I don't know why. Oh yeah, that's, by the way, I didn't implement those functions. I would need like to change the SDK. I don't do that. Hey, Bombo Galt. So basically, I just copied that. We were able to avoid also it resets the state. I'm not sure if I need to enable and disable. That's a good question. Yeah, might have happened. Anyways, in between that, there's like a lot of stuff. We need to like reset also the counter, and oh, I'm not sure. Yeah, I think the counter is decremented, so that might be, or is there like counting it eternally? Yeah, and the address needs to be set. That's the address for the, yeah, out. Yeah, that's the output. Input isn't used anymore, so we removed the intake of data from the clients, but that can be changed. What I wanted is to inline that. Maybe the CPU can help, because I tried to inline that and then we get a weird linker error. I'm not familiar with GCC. Undefined reference. that's weird. It looks like it's predefined, but it's not. Never declared it or whatever. It's only this instance definition. You got a code. Oh no. And then you have a good excuse to consume. Yeah, this what someone mentioned that ping pong mode. We would need like to flip the buffers or do like a buffer that's double the size, but or something because or how do we? I rather you did. Yeah. All right. So let's not waste too much time with premature optimization of the idle time because the idle time is really low. The transfer size needs to be bigger. Does it say? Oh, different semantics. Yeah, I use it. It's like it's defined disable CS here, and this is where it's used. Disable CS, and it complains here that it can be found. Please know my macros. Macros are an abomination. This is like it should be C or C++. Okay, this is maybe it's because it's C. No, C also allows inlines function. No, it doesn't like it here. Yeah, I don't care anymore. Let's not waste time. So I want longer transfers. What we can do, main next USB byte. Okay, this is also a thing where we might. Oh yeah, we're preparing the next. While waiting, we're also preparing the next message. I'm wondering if we can do the SPI packet size bigger. Let's try to make it big. And what would be the size? Let's do 16 then. No, I think it's, we can see, we can check that project properties. It's the ultra cluster again. Optimization. Huh? That will probably not work in the end. Not sure if I want to. And in the end, it won't work anymore. You know what? Let's do the following. Yeah, trying won't hurt, but we need to measure it and see if it even works at all after. Yeah. Check. Where is my? This will get hot now in here because that thing. Camera. Scope time. And we need okay. Animation is running. Let's single shot it. Okay. So it's actually shorter like that. Then we need measurements. Oh no, cursors here. We have delta is 6.5. Trigger is nasty. We run that. What is the trigger mode? It's edge. Weird. Okay, yeah, anyways, this is 6.57 and let's try optimizations on. It won't work. I bet it won't work anymore after that, because everything is like super nice and dandy. Okay. Oh, it still works. Okay. Okay. Wait a second. Huh? Okay. Okay, I admit turning on optimization saved saved a lot. Okay, no, it can't be. Let me measure it. Is it still 2 microseconds? Yeah, it's 2 microseconds, and then the idle time is also 2 mic. Yeah, probably. We can we? We could debug it and see what it does. It probably skips stuff that it determines to never change. Yes, certainly. We lowered. We lowered the time from 6.7 to 3.6 microseconds. Okay, yeah, improvement, yeah. We see a slight improvement in that, but we need also. Oh, you know what? I'm wondering if USB is faster as well. You remember we measured the USB transfer speeds? Okay, let me test that. If that improves. Nope. That's the same basically. Nothing happens there. Yeah, too bad. Okay, now it's also locked up. I need to restart it. Okay, optimization did a little bit for us. Now, shall we check out? Because if we run it right like this, this is still the result. So we are missing a lot of data is lost. A lot of data is lost. Lockup, a new thing? No, that the lockup is because I sent invalid data, and it was basically in a weird. It's putting the microcontroller in a weird state, or this. It's not. No, it didn't make the SPI. It only the idle time is halved, but if you increase the packet size, then it really doesn't do a lot. What we could try is to optimize level 3 level 3 codes now. We can run that. Let's see. I hope it's this one. O3 that does dangerous things. Yeah, let's not try it. Yeah, no. That's too much goodness. for us, for our. Okay, let me halt that. Stop animation. Now let's. Okay. Is it still working? No, it stopped working. Let me turn off and on again. What? Microchip requires you. Okay, this is still working now. Stop it. And let's try properties. I don't know if it will do anything. Optimize size, interesting. Why is that? We want this. Okay. Oh, it looks like we... it doesn't look any different. Maybe a little bit, a few less lost packets. Okay, this SPI is working really fast. Now, the next step would be next step would be to update the blade. I hope I need to also update this MCU. Okay. Weird. Why did it stop there as well? Yeah. Let me update the blade code because we have level duration. Yeah, I think premature optimization is too bad. Oh, there is one thing I like to talk. So yesterday on Hangout we are trying to I was trying to find an old school. Oh yes, why is it? It's not loading. What's the English name? Oh no. Okay. Teleprinter. Okay, I want to purchase a teleprinter. You know what happened? Um, I found uh, a nice one. Yeah, with Siemens T1000 for $150. Let me show you how that. Are you sure? Okay, here. This thing, $150. Uh, with a tape. Yeah, that's cool. Yeah, actually, um, if anyone can get me one of these machines, I really would love like this. I want to store the code for the ultra cluster MCUs on tape and read it in with that. So I want to use it as as an input device to the ultra cluster. That would be amazing. Imagine that, like reading from tape. I thought. Oh, that's a big image. So here is the tape thing, tape reader. No, it is like 5-bit words, but I mean, then you take 2 rows. You have some tapes. The sheeple, let's do it. We just need one of those. But $150 and I could have it. But what happened is I wrote to the guy and he returned. Yeah, that's all right. I mean that's software. Please. Yeah, please, let's not talk. If it's 1 bit, then I can still store it in serial. That's never the issue. That's always software. Anyways, I wrote this guy that I might want to pick it up. It's in Cologne, but near Cologne, and I probably be there in 2 weeks. And what he told me, his father wanted to his father wanted to show that it functions, make a video, hooked up 2 of those machines, and destroyed both of them. One was smoking, and the other one is only doing like noises or clicking sounds. Oh, that's so sad. We might still, I don't know, maybe we can still get one because it's so hard to. So Taryn, do you know what kind of, is it like 24 volts and then it was like. It needs like some kind of cool. Yeah, the tape reader puncher is like an add-on the side. So I don't know if the issue is usually those writers use like an AC stepper, which runs at 230 volts, and I don't know how you hook them up. It's usually like telephone line. So it is, what is it? 24 volts max? Or what's the... Okay, let neck tape. How bad can it be if serial connection from such a terminal might be currently? How bad can it be if you connect two teletypes wrong and they start working with one, releasing the magic smoke? I'm open to... Okay, classic teletypes communicate with a current loop, typically 20 or 60 milliamps, and often rely on external loop supplies pushing anywhere from 48 to 120 volt DC to drive heavy selector magnets. The good news, electromechanical teletypes are built like tanks, heavy-duty copper coils, selector magnets, and mechanical switches inside are remarkably robust. Simply hooking the wires up wrong usually just causes them to buzz, stay locked, open, close, or do nothing at all. They don't typically smoke, or they... Bad news, the magic smoke came from inside the teletypes. It usually means the component perished. Most likely a suppressor capacitor, often a 1970 paper capacitor that explodes and smokes dramatically when a high voltage spike, or an aftermarket solid state interface board hidden inside, or blah blah blah. The interface is interface power supply side most likely culprit. If you connected two teletypes or teletype modern computer interface couldn't correctly smoke power supply logic interface, but no, it's not a capacitor, die transistors, IC sniff test, unplug, inspect the boards. Okay. $100 baht is cool. That's like that's like 25 bytes a second. We will have a very performant code. We don't have a lot of RAM, so easy to debug. I would try to oh, because you have stop and start bit. Okay, then it's 10 bytes per second. So we have like, if we have 10 kilobytes of code, that's 1000 seconds. Okay. 1000 seconds is like a several minutes. I love it. I love it. Okay, you know what? I will write a guy that I'm still interested. Okay, I can't dox him though. Okay. Now you can switch on. Oh, I'm still recording them. Better load it from that tape. That cassette tape. Yeah, little cassette reader. If you have different hardware that I should use that you can give me access to, like really something that shows nice on a video, or like a demonstration of several, imagine that we have microcontrollers from the 2020s. Then we have a CRT as an output device from the 90s. And then we have like a teletype from the 60s or 70s as a storage device. Like, this is a century of computer tech. Yeah, I started at 56 kilobits per second. Okay, if you ferrite core memory, yeah. Okay, peeps. If you want to use Google Translate, because I will read the conversation in German, you should turn it on in 10 seconds, because I will start now. Hallo, ich habe zufällig deine Sammlung an Fernschreibern gefunden. Löst du ein Museum auf? Ich wäre mindestens an einem Gerät interessiert, welches Lochstreifen lesen und schreiben kann und vielleicht noch ein Computerinterface hat. Ein Freund meinte, das Siemens-Gerät hätte gegebenenfalls eine Schnittstelle. Ich wohne leider etwas weiter weg und könnte erst in ein paar Wochen vorbeikommen. Bist du zufällig auf dem Maker Fair in Hannover? Okay, that was my try to ask if they, by any chance, are going to the Maker Fair, because usually if someone has like these things hooked up and running in their hobby room, they're probably coming to Maker Fair as well. Anyways, Response was leider nein, und leider haben der T1000 und der LO 2001 gestern wegen einem Verdrahtfehler den Geist aufgegeben. That was his response. So the two machines, the one was T1000 and LO 2001. I don't know which machine. That I hope it isn't that the other one. No. What is the Fernschreiber? Oh, that's like in a really old school machine, I believe. Wait. Oh no, that was also a nice machine. 2000, 2001. Which one is 2001? Lorenz. Okay. Imagine using. Okay, so imagine loading a Lorenz Attractor code from the Lorenz Fernschreiber, Wählscheiben. Yes, you can get those with the bigger ones. I can get, actually, I found another Siemens like the T100. It's like only 20 kilometers from here, but this thing is like a whole cabinet, so I really don't want a huge thing. I can get one that is big for really cheap, I believe, but cheap, I think it was like also 200 or 300 bucks, but I really don't want a huge thing. Yeah. Okay, so Drehstrom. What? What? No, it won't. Okay. Continuation of the discussion. Was ist denn defekt? Ich bin ein wenig fähig, was Elektronik angeht. That was my response, that I'm a little bit capable with electronics. So, and then he replied, das kann ich leider nicht eingrenzen. Also die ganze Sammlung ist von meinem Vater, der die Geräte damals von der Post mitgenommen hat, als die nicht mehr gebraucht wurden. Er wollte die beiden Geräte gestern neu verbinden für ein Funktionsvideo, was irgendwie dazu geführt hat, dass das eine der beiden gequalmt hat und der andere jetzt nur noch Klack und sonst nichts mehr macht. Welche Teile da jetzt einen mitbekommen haben, kann ich leider nicht sagen. Okay, yeah, I mean, switching a capacitor or like finding, it's probably, even if it's like a burnt coil, a solenoid, you can get like some used solenoids, or we can rewind solenoids. It's like mostly mechanical. The only issue that I can imagine is if there are like okay, we can switch transistors if it's like transistor logic, but if there's like a chip, um, then it will be difficult to replace that, the broken IC or something. The T1000 from, okay, I'm responding now. Ich wäre trotzdem an dem T1000 interessiert. Vielleicht kann ich es wiederbeleben oder zumindest die Lochstreifeneinheit wie, retten. Ist für ein Kunstprojekt. It's art. Okay. Let's see, maybe. Okay, and the other thing, T. Okay, so the other one is Siemens Fernschreiber T100S. I show you. I don't want to spoil the source. Why is it so slow? Kleinanzeigen is slow. Okay, yeah. Probably you can find it anyways. But I will. Okay, here is the image. So this this is the other one, which is functional, or probably functional. Here's Streifen. Just look at the keys. They're like typewriter. That's I really don't want that. This is too big. Companion cube. 76. Is there? Yeah, it has like a cabinet below that, so you can store extra types. Yeah, of course. It's always about with phone lines. That was like how telegraphs were transmitted. Nice. So that I can check what the response there was, because that's like close to Hünfeld, and in Hünfeld, which is also not far from here, is the Konrad Zuse Museum. And if you, a similar machine like that is also displayed there, and it's even like behind glass, so nobody would like touch it or whatever. So I was asking, oh, by any chance, is this from the Zuse Museum? Uh, and then I asked also if they have like different machines as well, because that one is quite heavy for my taste. Hallo, Hünfeld ist zwar um die Ecke, aber das Gerät ist nicht aus dem Zuse-Museum. Einen anderen Fernschreiber habe ich nicht. Dieser ist aber in einem Top-Zustand. Vielleicht gleicht der Zustand die Größe aus. Auf die Größe kommt es nicht an. Alright, anyways. Yeah, I will just keep it in mind if there is like, if I can't get the T1000, then it would be so nice to. Yeah, that's what we discovered last time. So basically, an interface to the ultra cluster would be quite easy if we just use a chip or something, like translator. I even have translator modules from RS232. They're like, I think these are the same modules. Yes, the same. I have those. Yeah, we used that for DMX, didn't we? There was a stream about that. Let me check if I have it here. But I think I have a separate box in the basement for that. Okay, might be wrong then. Hmm. RS485. Okay. All right. So yeah, we can basically translate that. But is it all in done in like discrete logic in that thing, like with transistors? It's not tubes anymore. Is there like a T1000 teardown? Crypto Museum. Do you have? Crypto Museum. Where is it? This is so annoying. Yeah, here, no discrete logic. That's like, if that's molten, that will be hard to fix. Okay, D26, but oh, is there like a description for that? Oh no. I hope there is no like EEPROM or anything. Oh wow. Okay, interesting. You can see the trace on the back. FTZ number, what is that? Sonic. Sonic, you know what? It looks like my plug-in, Twitch plug-in might be broken because I can't hear anything. Let me test. No, it's working. What is the PSTN? That's the T1000. So 76. That's like state of the art then, I see. So I can hook it up to my analog line and then human skin cover. Okay. Anyways, dudes and dudettes, let's continue. So if you can find a working device, T1000 or similar, like size wise, they're like I really want something like these beige, like that, not like the really old school crusty black stuff from the 50s with the dial. Dial could be there, but I'm looking something from like more 60s, 70s, maybe 80s. They can punch tape as well. Or we will make it. Now I made you hyperfixate on that topic. Okay, let's check out cluster code level 3 min because we want to no electric type. I don't want a typewriter. I want really with something that, hey Ricky, something that can read like the tape, or if you have something that punch cards can read punch cards, a machine, so we can store code in punch cards. Yeah, but I want something with mechanical data storage. If you can get me anything like that. You miss vector graphics? Okay, now you're all hooked. Not we want it back though. Yeah, you spoiled kids. You all want just Tektronix vector screen. Yeah, give me one of those. I want that. Vector. If you can. Yeah, I can build it. We can. You know what? Um, we can use the 3D printer to print cards with code on them. Just need one layer. You want like a dense the file, yeah. So if we print like the cards, we can just, yeah, that's it. Photoresistors and be good. Easy peasy. But you know what? Cards are way more difficult than tape. I think making a simple stepper and punching tool. I have so many solenoids here. I could make a punching tool and what kind of tape would you use? Like, would you use a paper tape for that? Or just a laser and laser? Punch tape. We can use some kind of other paper tape. Here. You just take this paper, is it paper? Something like that. You can just use anything. Papierband. Länge 250 Meter, 10 Millimeter, blau. $5 bucks. 10 millimeter, 250 meters. Well, you can just use like you can punch them. You just need to start and then let basically your index wheel will punch the holes as it feeds, and that's it. Storage guys. Yeah, I checked hard drives. I really need a new hard drive for my NAS badly. I can't afford a 10 terabyte hard drive. What? It's so crazy. I won't be paying 400, 300 bucks for a 10 terabyte HDD. It's not even SSD. It's like typical hard drive. Okay, can we get any other paper tape? Tractor holes. I bet we can use like something else. You can get like paper stuff. YouTube adverts say double price. No Fonte J. Long time no see. Ah, yeah. You have circular writing on those internal 8 gigabytes micro SD cards. All right. Mirroring. All right. We wanted to open, yeah, to try optimize level 3. Oh, yeah, that's that quota already. And we need to... Wait, did we program? Yeah, we programmed both of those. Uh, 10 terabyte Western Digital Red, you say? I think I bought Seagate recently. We can check my NAS. I think I hated Western Digital because they were so loud. They're clicking around all the time. That can't be good if you're computer. Yeah. Okay, health check on temperature because I'm sweating. 31, 29, 28. So around my computer, it's actually, oh, the hottest is behind my computer. But anywhere else, the temperatures are dropping to 29, 28 degrees C. Yeah, we need to check. This is what we get here. SPI I2S receive data. Oh, oh, that's not using DMA at all. That's just, oh shoot. That's why we lose packets, because it's oh. Okay, we can remove that delay because we know it will work. Send SPI also. Let me check. Nah, that's just looping. Oh no. I had DMA client code for that, I believe. Two microseconds. Okay, but I don't know if I can do this. Let's let me detach that because I need to take. It's a long time I used. So what is the verdict? What? This is crazy. Okay, I will try. No. I'm programming a CH32 board, but I need, I need some pogo pins because, oh no, I don't need pogo pins. We have the interface here. So this interface can be programmed like this. That's ground. That's ground. That's SDA. Okay. Blue pill, what? CH32V. Okay. Oh, it programmed. Okay. Okay, I programmed it. Now let's plug it in again. Let's plug it in again and see if we can get it working without a delay. Nope. Okay, that delay is actually needed. So I will plug it in again and add at least 1 microsecond. Oh yeah. Output and program. Okay. flood. Okay. That is weird. It's really 2 microseconds. Did I really determine it to be? So at least I need packets of 32 for each row, because if I have to wait 2 microseconds for the chip select lines to be set correctly, then there is no optimization there that I could do. Oh no, that wasn't the reason. It's not functional at all. Uh-oh. Now I know. I need to know what I changed. Because that code level 3 min yeah, but it's not that. Let me see. I have no clue. Oh, here. Change the frequency. 48, 96. I updated the frequency to 96. Okay, this is external. Wait, is this blade? Because need to check which version of blade that is. No, that's 4. You know what? If I increase the frequency here, then I need to increase the frequency elsewhere. So you know what? Let's remove that. Let's restore system. No, yeah, system. .48. Why is it 96? 96 is too fast anyways. Okay, let me turn it on. You need to be careful so I don't destroy. That will work again. Okay. I need like to revert all my changes to see and then start one by one, because I need to know. Okay. Nope. That's not it. Huh? What is the code? How did I kill it? Source control. Okay, how do I compare? Can I see view as tree now? Okay. Let's see what I changed. That's level 3. Level 4. Okay, level 0, ch blah 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 blah. Level 1, level... core. It's just, oh no, that's just the whole code. Peripheral startup. Okay, that's crap. This is similar. Oh, wait a second. I might have, turn that off again. I might have USB LED bus SPI client host. These are shared. If I changed anything in there, so I need to check what did I change here. There is nothing, basically nothing. Host client. Yeah. No. That's different library. It's not like that. That's not the same code. Okay. host do I use? SPI. This is the prescaler. Okay. 16. I thought we might have. Okay, let me check this working version but slow, and we had optimized working version animation level. Okay, level 3 didn't change since then. High speed support. SPI host, yeah, we are working with SPI, not SPI host, and that's the difference. But what is the system speed? Okay, sanity test, sanity check. I will plug in any other blade, so I know it's not the host. That's weird right now. Okay, it's not the host. That still works. So build artifacts, check into sets. Yeah. Sorry. Sorry, not sorry. I don't know if I removed now. It's so weird that it. Okay, I just added. I don't have an ignore file. What else could have happened is that we are a startup system. Oh, that's level 1. Where's level 0, level 1? Level 2. Wait a second. This is the wrong code. I need to upload level 2. Oh. Oh. Okay. But level 3 is also not very optimized then. Level 3 min is like this. We should start from level 3 then. Packet size. Send message. Yeah, we might lose data already here. Okay. Let's get this running again. Let's download it. Oop. This will work again. Okay, found my error. Yeah, wrong code. Okay, let's forget it. Forget everything. Now let's optimize level 2 and then level 3, because level 3 is also, we changed the clock speed back, which is no good. We were at 96. Haven't we been there? Okay, level 2 is system C. Oh, it's using the internal 120 megahertz clock, which is alright. Then main, we can do, what we can do there is we can try now removing that delay here, because I think we figured it was fast enough, was it? Oh, okay, that worked. Let's do it once again. See if it's still communicating or if we are losing packets there. Nope, it's looking good. Okay. What we can do now is we can further optimize it. But I'm not sure where the bottleneck is now. So we have a bottleneck somewhere down the line. It's either level 1, level 2 or level 3 or all of those. So what we can do is we can try to get a higher clock speed on that. Init SPI host prescaler, which we might be able to use a higher clock here between the CH32. Okay, let's try higher clock speed here. Okay. It doesn't look like it's changing anything. So certainly wasn't the bottleneck, but higher prescaler works. Okay. Now next step is optimizer, because we are processing data in let's not unplug it while it's running. It is a clear line moving up and down. It's like a wave, not like if you lose packets you have like, yeah, I should whatever. I can still, I mean, we have spare cards, at least I plan some. The optimization size, let's look for that. Oh, you mean there, yeah. I can rotate to another slot. So let's plug it into another one. 50s, are you kidding me? It would be. Oh, there are some packets that never arrived. We have LEDs that are in the original state. Okay. Let me plug it into that one again. It could be, what is the highest distance? I think this is the furthest away. We never tried this one. Uh, uh, uh. Yeah, no, it's the same. Looking, I think it's worse with optimized code. It's probably losing the packets on the other layer. So what I will do now is I will leave the optimization on. Let's keep that in mind. Optimization is still on, and now we will update. It's quite hot. We will update. I will get the pogo pins and we will try to update. Do I have any pogo pins here? Nope. Update level 1 to work faster. Where are my pogo programmers? Okay. Parts. PCBS. What is PCBS? What does the S stand for? Oh, for your PCBs. Oh, yeah. Sorry, my brain. Printed circuit boards. It's the plural of printed circuit board. Oh, where? I can't find my pogo pins. I need pogo pins for that. Don't want to use the printer because we only want to update one row. Oh, you know what? We need to update more than one rows, but. Damn. Bitluni searching things. Your favorite action on the stream. Okay. Yeah, brain, yeah, this is just too hot to function properly. where is it? I moved things around, now I can't find anything anymore. It's probably just on the table and I can't see because... Yeah, but my eyes are getting worse as well, so... There's a bunch of wires. I had it in a box like that, the pogo pins. Is it behind my screen? No. Yeah. Yeah, I need also a 55-inch OLED as the main screen. They are not very expensive nowadays. Like a really bright one to burn my retina. Ah, there is another box of wires. Yeah, but I had to reorganize a little bit because I found it! I found them! Here! My pogos! I found them! Yes! Amused, hello. Amused moose. So this is good, but this is the, I need to, this is clock, and this, and I need a ground line. Ground needs still to be connected. Give me a nice ground, my friend. So I never used an SDM before, even though my T-shirt says otherwise. I'm sorry, I can't recommend any SDMs because I never tried any. It's not that I don't like them or anything. I have no opinion. They are probably good. Okay. I have no clue what is what here. Okay, level 1. We need level 1. Well, what am I doing even here? I need level 1 min. That's main. That's basically the same. We can change SPI here. That's max what we can do, but what I can do is that's also okay. I will try to compile and upload. Hope it does anything. Nope. That doesn't work. Oh, it's not powered up. You just need to find the right order of pins. Okay, that's the right order of pins. Okay, now we will try optimization. We will use O2 and we will reduce send message. We will reduce the delay to 1 microsecond, okay? What was it again? Oops. Okay. Why no? Huh? This one refuses to write. It's also quite hot already. Let me turn it off and on again. Okay. Fasting. Dun. That one refuses to work. Let's reset. Hey TMK. Okay. We really need to convert the code to DMA for level 3 and then copy it to level. Okay. Blade is getting quite hot, must admit. Okay, now we updated optimization and delay lower to 1 microsecond. Oh, that's hot already. That's like the blade is quite. Let me check that. Even not powered on. Okay, 42. That's alright. Let's use a different slot. Power it up. And same weirdness going on, but it's still working. The bottleneck or the failures are happening between yeah, some Pavlov thing going on then. Okay, I think I need to optimize level. You know what? Let me turn that off and check. See if that worked better. No, it's the same. It had made no difference whatsoever. So the bottleneck is actually level 3. It's basically it basically the here. So this is optimized, this is less optimized. This is the old code, and this is the new code. And we have a similar level of packet loss here. Yeah, I guess the bottleneck is on level 3 then. Let's optimize that. That is easy because in that case we can just... Which one is... Actually, I don't know which one attaches to... Oh no! Wire detached. I hope it's the other one. Okay, let me turn it off for now. To solder that back on. Let me check level 3 min. Okay, it might be the right one. Let me check. No. Both are remote communication, okay. Uh-oh. That didn't work. Let me check out which one it is. Is that one working? Huh? These are attached to the same? No. This can't be. Why is that not working? Huh? Okay. Huh? Do I reprogram both at the same time? Because that should be, if I zoom out, this plate and this plate on the opposing sides. They are connected to different microcontrollers. Why wouldn't it work? Huh? I'm so confused. How is that? How is that? Or is the floating wire somehow? No. Oh yeah, you mean... No, it should be floating. Here. Oh. It might be crosstalk. No, P bus. Wait a second. How do you... Oh. P bus E14, E13. Okay. I guess I don't have to program both because I am programming both at the same time. That's why debugging doesn't work that way. Oh, so bad. This is bad. Yeah. Yeah, the programming pins of both microcontrollers are connected to the same parallel bus. How did I miss that? This is terrible. Wait, huh? Doesn't... No surgery. Because I need that parallel traces. But I also need this thing to work. Why don't I see anything working anymore? Huh? Hey, did I miss something here? Oh, I changed the clock speed here. Wait a second. We changed it to 48, but we need 96. It was overclocked. Now it should be working again. Yeah, that's that. Okay. Oh, the other one doesn't run. Let me check that. If yeah, now it runs. So the reset didn't work for the second MCU. Oh, weirdness. Okay, optimization. What clock speeds? We increase the clock. What we can try is we can increase the clock here. That was the bottleneck. Okay, let's record. So let's, if that was the bottleneck, let's try to increase with the optimized code on level 2 and 1. We can try to do that. Okay. Oh! Actually, we have fewer packet losses. Interesting. Okay. We have fewer packet loss. Now, okay, I'm missing a few rows now. It seems the same rows are always skipped. It's getting worse. It's probably like the synchronization is getting worse and worse. But what I need now is to use DMA. Or let's try even faster. Let's try that. Prescaler of 4. It's quite long wires. It might still work. Okay. Ready? Oh, it's so weird. These two rows. Now we might lose packets on another level. Because now we don't have like blocks that are missing. We have single MCUs that are dropping out. Here. This is how it looks like with that prescaler. We stop that, revert to that. I need like the same code on all levels. And this is with this prescaler. I don't see that working. Okay, let me stop again. Let me try something really wild. Prescaler of 2. Yeah, that's losing everything. So it's actually the bottleneck is we just shifting the bottleneck up the row. But if we use DMA here, that might work. Let me just do 8 again. Yeah, that's the classic. We're losing some packets. Okay. All right. Interesting is that the same rows are dropping out. They are more or less in the center of the blade. So the signal is probably like disintegrating the most in the center of the lines. Okay, we have that. Now we can try to make DMA working. Let me check that. Okay. So, SPI hosts. This is our implementation. Okay, ITT, get well soon. Get some rest and a good night. Bye. Okay, I think we can try to just get the code from level. You know what's weird? On level 4, we are using prescaler of 2, yet we're not using any DMA there. So this is really like probably losing packets there as well. That's bad. But I can't switch right now. You know what? I can actually. This one here, the spare one. Okay, let me try to. But then we won't be able to process USB again as fast. No, that will hang. Okay, we had that figured out already. All right. What I will do now is, let me these loose wires. Let me take them down so we don't have any shorts here. Okay. we need to get to that for that prescaler to work properly. We will change everything. Okay, we will copy that. That code seems to work. SPO. We don't have client though. We're not using client. We are only using host here. Okay. Level 3. Let's check main. Okay. SPI host, SPI client. And packet size is now it's 8. Where is defined? It's not defined here. SPSTA is the main. Okay, let me check that. Packet size. Okay, SPI packet size is 8 defined. If not defined, okay. SPI host. Send message. And that was 8. Let's keep it that way. SPI RX complete. I think I used it before. You who work. That's what we did there. SPI client transmit receive. RX complete. Okay. So this is basically what we need to do. Main oh come on, SPI client. Okay, we need to include that. Client and host. Is that done? Is this in just lib? Yeah, here. Okay, we have that. SPI client transmit receive. So let's do that. Buffer bytes is 1, so this will be out. 8, and this is basically 1 buffer byte. I think I figured that out already, so message out will be, it's not, is there anything defined here? No, okay. So it's the 9. That case, buffer bytes, what is it? Oh, packet size is always the same. Okay, buffer bytes is that. Transmit, receive. Pause packet size, that's basically, you know what? I will take all this stuff. Put it here. And then if no, first one is comment LED. Wait, this is plus plus, pause 1. Okay, if equals comment LED and in 7 is, that is my like signature byte. Oh. We have no position here. It should be all DMA. Send message, finish SPI, send SPI host. Okay. We don't need all that. SPI client transmit receive, that is what we try to SPA host transmit receive, and will be CS in into one idle function is nothing. Okay, so now we define basically that could be our test. You know what? We will take it as a test. So we have, oh no, we need 9 bytes. 8, okay. That's the buffer byte. I hope that code works. I mean, at some point I have tested that, but I can't really remember. So what we need is into in host. Let's do it like that. In client. Where is this? Why do I need to pause anyways here? Is this just to save? Yeah, that's not, that doesn't need to be volatile here. Maybe I put it volatile to have it be able to debug. Okay, volatile. That's in client. Let's rename that. So that didn't need that, but we need it right now. Okay, so we put it here in client. And host. What did I change here? Oh yeah. Okay. Let's try to compile first. Errors. Oh yeah, let's send message. That's all covered in the new functionality. Okay, so let's remove that. Okay. And that's not packet size. Okay. Oh fuck, that's the wrong MCU. Okay, do I still connect? Okay, yeah. I uploaded it, but it doesn't work. So, how do I Oh, I'm actually debugging it. This works as really interesting. Okay. Okay, let me turn it off. Let me turn it on again. Let me start the debugger. Run it. SPI2 RX complete. Oh no. Okay. So we're never receiving that flag. So either DMA is not running. Channel 4. Channel 4. SPI client. DMA1 channel 4. SPI2 RX buffer. DMA1 channel 4. We don't get that. So it's not entering this handler, which is okay. So configure line for client CS packet start detection. That's what we GPI open source 12. external interrupt, but where? How's the external interrupt? That's external, this one, okay. Let's check if we ever get this one triggered. Where is it? Good night. Where is this defined? SPI client. 140. Oh, here it is. Okay, so what we can do is we can try to get this interrupt. This is the reset. Should be triggered once. No, it's never triggered. Okay, interesting. It's never entered as well. Okay. Am I wrong with the chip select? Not sure if it's in a weird state. Okay, let me just turn it off and on again. I can also turn off the oscilloscope. I don't need that. Okay, so. Oh, I pressed F5. Oh no. Alright, okay, F5 is alright. No. Nope. Interrupt is never triggered. So let me check that. Do I miss something? Hey, Equinor. Yeah, we're trying to make DMA on the client side work again. It's weird, I'm not getting any interrupts here triggered. I should, and if I set too many breakpoints, it will not. SPI transmit receive channel. Okay. Enable. So That's weird. SPITX. Line 12. Wondering if this is rising, falling edge. Line comment enable. What is line 12? Okay. We get I want to dox myself again. Okay, let's look for line 12. What's the definition? Okay, let's look for GPIO. Interrupt events, external uh, 15. Okay. What's the lines? Oh, that's basically line 12. How does it pin source 12 external config B 12? Is that the okay? Let me check. B12. Chip select. $33. Oh yeah, here 33. Yeah, this is correct. Chip PB12. Okay, something's weird going on here. Why don't I get that initialized? Delay init SPI host. That's out. Oh shit, I'm letting in all the... What kind of big fly is that? Oh it's a dragonfly or something similar to a dragonfly. That thing will die in here. Then don't bring it outside. Okay, I will leave it. I really don't want dragonflies to die. They are eating the mosquitoes. Okay, SPI client, let's line config. Flycan. ESP32 Super Mini. Modules or is this like a breakout board? I don't know. Really, that's up to you. What are you looking for? Blinking LED would be the first. Yeah, can you just plug them in? I would, if the first board, I would give it some headers to plug in like dev board, and just like put some LEDs or whatever. Try Charlie plexing, because Charlie plexing you can have n times n minus 1 LEDs. Like if you have n pins, you can have a matrix of n times n minus 1, which is quite a cool project for the beginning. I will do something with some. LEDs cost nothing. Just get some off eBay. Really, like SMD LEDs. They cost nothing. That is like less than 1 cent per piece, or maybe 1 cent per piece. Where are you located? But it's always cool if you have like a soldering iron. Yeah, you can get them even off Amazon. Also, like true hole LEDs. If you, I mean, you can do SMD if you like to. That's cool. Oh shit! I have some bugs in here now because of my open windows and the lights on. They will sleep in here now. Shoot. Yeah. Yeah, you just get like an assortment of Amazon for $6 of different colors. Don't do like RGB. You don't need to make it complicated. You can just start with a single color thing. SMD, what is that? Here, LEDs. I wouldn't take the big ones. 08, 05. They're easy to... Oh, they're even wired. Okay, this is not many. Let's say LED. What about assortment? Red 100. No, SMD, dude. So hard. Here, 100 pieces, SMDs, whatever, $4. I would. Yeah, 9 amps is need quite some thick or like solder reinforced traces there. Yeah, no. Yeah, 80 amps. I should turn it off. Trying to debug right now. And it's getting hot in here, of course. But I have distributed the 80 amps, so the most that one blade is pulling right now are like 4 amps. So if you have like a regular PCB trace, you can assume it's like 3 amps max if it's quite wide, like 1 millimeter. Yeah, oh no, this huge bug is now caught in a spider web. It's struggling. Ah! No, it freed itself. Stupid bug. Yeah, I know. I love spiders. I leave them in here, but this bug is huge. It's like a 1 inch big. Yeah, I always find like a corner where they drop the carcasses of the dead, like I don't know whatever they eat. So that's very satisfying to see what kind of bugs they eat that don't like spread in my living space. So I'm really always having spiders around. But in here they're hiding. I think they went all downstairs because this room is too hot right now. Debugger. Yes. Okay. Let's try to find out why I can't get this config. Line BP. Okay, X. Rising, falling, line 12. And let's see if that breaks. Actually, it does. But it never enters the handler. $15.10. Why is it $15.10? It's because probably line 12, but why? Okay, now I need to check. Where's the description? Okay, I need support. Or you know what? Let's not enable it by that. Let's skip. Start with that. Oh, you don't have resistors? Like, okay, wait. 0603 resistors on there? The footprints. Usually you just need better tools, like tweezers that are very pointy and a booklet with. Okay, if you don't have like a assortment with resistors of 0603 resistors, then it's difficult probably. You could, yeah, it's alright. Yeah, try something simple. Ah, I'm melting. I can't concentrate anymore. Okay. What I want is set. So what is this? SPI packet size. Oh, this nasty bug. It's walking across my microphone right now. Okay, you know what? Let's start. Let's do this. Since we are not entering anything there, let's try to yeah, try just anything small. I'm not receiving any packets. Can you hear the bug? It's walking on the microphone right now. Stupid thing. I'm not sure if it's like a stinky bug, so if I try to catch it, it will... Okay, I caught it. It was on my microphone. Now it's outside. Okay. Ah, fuck! It was a stinky bug. No, my hand. Oh, thank God my microphone doesn't stink. I need to wash it. Ah! Be right back. Okay. I'm back and my hand is not stinking anymore. Ah. And since the window is closed now, the temperature is rising. 32 again. It's 30 over there. It's like 2 degrees more. Want to debug. Start. Nothing. Okay, what am I missing? So, before we had that three, four, five. No, that's host. Okay, no, not host. 12. B12 is correct. 12, 13, 14, 15. Okay. Uh, 13, 15 is floating. 13, 15 is floating. 14 is floating. All are floating. Alternate function push pull. Oh. Pull up. Alternate function. Wait a second. Huh? Wait a second, why is this different? Am I using alternate function here? It's not alternate function. That's weird. This is completely differently initialized. Hey Johnny, we're having a little bit of some issues here. Node slave, prescaler. It's not like, wait, prescaler is not needed here. SPI 2. That's weird. Okay, so let's try that instead. Not sure if that changes anything. Okay, am I receiving? So weird that everything is floating in that case. Okay. Yeah, we are on receiving side, not sending. Okay, the configuration was bad. Now I need I need to check if no, this one also isn't triggered. Okay, let's start over. Okay, can I see any watch variables is basically okay, how do I okay, you know what? I need to disable the optimizer again. Optimization none. Because that's not easy to debug now. We are receiving packets with DMA. Now I need to check what kind of var create unable to. Okay, I can't, my watch isn't working. Inclined, okay. Let me kill that. Because that's on the stack. Let's put it here. Volatile. So we can debug it properly. Okay. G, that's correct. Okay, so we received the packets correctly. I think 103 is 67. Is it? No. What do I this is 103, yeah. So that's actually a correct packet. But then host transmit receive doesn't work. So let's figure that out. Yeah, but it's the great reset. It's like only from, it's a meme from last year. It shouldn't be qualified. Okay, transmit, receive. Oh, why do I not see it stop? Host, transmit, receive. Reload. Out. Idle function. Busy reset. Disable CS. Okay, let me debug that. Let's see if TX complete. It seems like TX is complete, but I think there might be a wrong configuration again. Pin configuration. Yes, Susanne Daubner. But her was gut genug. It was a little bit weird, like on first try. I mean, mine too, right now. My voice is breaking from too much talking. Yeah, that was also a candidate. Susanne Daubner. It's so funny to watch her do that every year. I have even stickers from her with from last year. Sus was one one of the words last year. Okay, I guess wait a second. We never get here. Host, transmit, receive. What is happening? Where are we? Rx complete. Oh. We're not receiving anything. Wait a second. Okay. Oh, we are receiving it, but we are never. What's going on? Oh yeah, because it's a volatile and we can't pass volatile, whatever. Okay, I mean I proved that it's alright. I need to get init SPI host. I need to check that, but now running this. Oh. Uh-oh. Weird state alert. Ah. Let's not break anything. Okay. Uh-oh. Yeah, it does work. Okay. SPI host. We have still the breakpoint? Yes, we have the breakpoint. So, okay. It never returns. Aha. So the interrupt trigger still doesn't work. So what I need to do is basically do this stuff. Here. Oh, maybe I need to activate it. It's a peripheral after all. Oh, yeah. Wait. Okay. I can't see it. Okay, it's transmitting, receiving, but I don't see anything on the other side, okay? So let's check out why. We need initializing DMA. Now I need to see. Oh, prescaler is too. Oh wait, I changed the code. Host transmit. Oh, wait a second. It's too fast. What as prescaler did we use there? Oh, that's client. Hosts 8. Okay. SPI host. And then 8. Let's do it. Probably 8 might be still not good enough. Let's try 16 because we are faster now, and Oh, we also need to use it, not only define it. Let's leave it here. Still not seeing anything. Okay, let me restart so I can be sure it's not the prescaler. I didn't expect that I have like to reconfigure DMA this stream. That's really boring. That's not hardware at all. I'm sorry about that. Okay. Yeah, that's not doing anything. Prescaler, and we use portrait. Let's do 64. I'm also wondering if we could enable the, let's see if the external interrupts are somewhere here. As peripheral DMA SRAM. Timer. Watchdog. Actually, I can't see it. So I was wondering if if I forgot to enable it, because this code I might have tested it already. It feels like, I mean, it's months ago now, or a month ago, so I can't really remember. Let's figure out if we have the right settings. Now that we set the prescaler, it's quite slow even. We should be able to, okay, let's debug to see if we get any packets sent. So we send the right packets. Huh? Huh? Doesn't work anymore. Where am I? Do I deactivate the breakpoint? Yeah, I have no breakpoint here. Huh? Alright. Let's start all over again. I don't know why I don't have a breakpoint here, but doesn't work anymore. Huh? What? Why? I didn't change anything except the prescaler here. Ah, all those mysteries, my friends. Okay. That's only host. Did it break things? Okay. Let me do 4. Is disabling CS maybe an issue if it's so slow? Might be weird. Okay, okay. Let me try to figure that out. But why would it not work with... Doesn't work. Wait, is there a copy paste code? Am I changing actually the priest? No, it's SPI host. SPI 3 hosts Failed program and verify. Oh! We had some success here. Huh? Okay. Okay, maybe the debugging just doesn't work. Because that was weird. Okay, let me reset that. 4. Oh no. What was it? Prescaler 4. Oh, I'm actually seeing some LEDs there. We had some packets going through. So actually, I upload it. That doesn't work. Okay, let me check again. Okay, I had like one LED. Hey. If there is a shift in data for some reason, that would be weird. Host, transmit, receive. Okay, we transmit, receive. Maybe we just need 0 here. That was an issue only with the delayed incoming data. Let me do that. Fail to program and verify, alright. Okay. We are receiving packets, but we can't send them, so let's do the following. Startup. Okay, we have no overclocking. Our level 3 was overclocked. What is this now? Where is level 4? Here. Let's just copy that part. That's our host side transmit receive. Okay, that's blah blah current buffer. In clients. we don't do anything in hosts. Okay, and let's do prescaler 4 and hope that works. Okay. Nope, nothing. Stop. Two will never work. Yeah, it's not verifying even. Need to check if the breakpoint. Nah, it can't debug. Yeah, it's too late already. People went to bed. Oh. Sorry to hear. Transmit, receive. Okay. Let's debug that. Where are we stuck? We are stuck somewhere really bad. There won't be debugging, most probably. Oh, there is debugging. Okay, yeah, we have misaligned data. We had a flash somewhere. Now it's stuck. Okay. That's prescaler 2, prescaler 4. Yes. No, they're cheap, like 20 bucks per piece. Can get nice FPGAs. And I have worked with them and we will work again quite soon. I need to process a lot of data in future. Okay, it's dev board. Or let's say, yeah, you can get dev boards for 30 bucks. Okay, that doesn't seem not to work. I think the data is misaligned now. Yeah, failed to program. Yeah, the Chinese Gowin based The Pete Tang FPGAs are super cheap. Also the Ice 40 based. Okay, yeah, that's not working. Hmm. Yeah, we won't get to that. I still need like to figure out the issues with the DMA. I'm sorry, we have to postpone to next Tuesday. The next stream is on Tuesday because on Wednesday I'm at the championships, not gymnastics, Kunstturnen, what in Frankfurt. Artistic gymnastics championships. No, that's like where. So I can the Tang Nano 20K can completely emulate a DOS machine, including HDMI output for $30 or something. I don't know if they are still as cheap, but the Tang Nano 20K, you should check them out. You get like the example code for that. I mean, there's like some bytecode for HDMI, I believe. I don't know. With sound. No, that was like open source. We did this on our tested that on our stream at some point. Bop, bop, bop. Where is it? Where is it? Let me check that. No, that's not showing anything. I can't. You need to check the examples. Tang Nano 20K. Was it? Yeah, 20K. example codes. Okay. Okay, there's an Atari 800. Wait, where was it? FedEx? Yeah, if you use your FedEx account, then FedEx will charge your account most probably, and you have like an additional fee of two $2.5. Usually it's like $30, but we have like in Europe we have like the option Euro packet, which is like $15 or $12, because they bundle different. I don't know if there's like a North America option as well. They will bundle basically many projects, send them over to their base here in Germany, and distribute it from here. That's the Euro packet option that we get here. So I usually, oh no, you can't use Euro packet with assembly. No, you just want to buy PCBs. That's working with Euro packet, but not assemblies. Assemblies I have also like to pay shitty DHL, DDP, is it? Whatever. It costs more than the boards in the end. But you can also global line. Yeah, global direct line. Yeah, it might take up to 15 days, but it's cheap. So if you want to save money, I think I used global line for LCSC components, and it's usually within 10 days. It's there. That's the like most economic option. It's the same like you would buy something off AliExpress with not the choice option. Or maybe choice options, similar. Choice options also like 10 days. Okay. My dudes, I don't know. I usually use it for SAC because I feel yeah. The Shipu, are you working on any new badges or handheld computers, or what is your latest project where you're awaiting your PCB parts or PCBs? Ah, shell like board. So you want nice. Will it get a face? You probably want to add a face to the robot. It should have a personality. And you want to play around with oh, do you want to like try the high speed? If you want to use the USB programming option, you probably can't do it with the high speed pins. You can do it only with the no, I mean the programming of the CH chip, you you can do it with the USB if you, I think it was pull down or pull up on the minus or something. But you probably know that's on the full speed US, no, yeah, full speed USB pins, not the high speed. Ah, but zero. Okay. Oh, nice. Okay, cool. So you want to play around with that? Do you want to try the highest possible speed that you can do with high speed on that chip? That would be interesting if you can achieve higher speeds than what my abomination there is capable of. Oh, there is a port. Nice. Yeah, that's what I would expect. Okay, I don't know how I can debug it. You know what? I can debug it, the packets, if I take a blank PCB. What? No. No, I don't want to send it. If you were like my neighbor, I would hand it over to you because I have like some stuff that I wouldn't use anymore. Okay, we can test things. I'm ready. So what we seeing, what effect? That's all right. Come on, it's not that much. I will. This water blades are hot. This thing is running hot. Yeah, gross. Oh no, I don't know which one I unplugged from where. I like different versions of the. Yeah. What I can do, I have a pips. So I need to test the DMA transmit between level 3 and level 2, and this is a blank PCB and this is level 2, so I can attach wires here and we can scope it. You scope time. Okay, but I need I need the microscope and I need to attach the wire to the right pins, which is difficult. Where is blade base cluster blade octal blade? Where is it? blade edge. Okay, here it is. That's what I need. Then I will attach teeny tiny little wires to it. Yay! Don't do assembly on your first try. You will be very disappointed. Just saying, I mean, it can happen that you are more thorough than I am, but usually it fails. And then you have to botch anyways. Alright. Do I have no lights in? Here's the lights. Blinding lights. Where is okay. What? I judge you? What? I'm confused. I don't. Oh yeah. Okay. Okay. Out of ad, you get ads. Oh. All right. Let's see. Where is? Chips. Oh, that's easy. Look at that. These 3 pins. Master out, slave in, master in. Okay, we need 1, 2, 3. Oh, you know what? We will add all 4 pins. That's perfect. Do we have ground anywhere? Ground. The next ground is basically this here. This is a ground, so I will add 5 pins. Okay. Let me cut that wire to length. That's just for debugging. Oh, I need another wire. Oh, there is more wires. Okay, you won't be able to see anything except maybe my back, how I am, because it's too far away and my camera isn't attached. Wait, I could try to reattach my camera. Like this is a mess. I have a lot of stuff going on here. Wait, where is the power supply of the camera? Okay, also, hey, there's nothing attached here. Yeah, this is not hooked up. Sorry, guys. I will quickly solder that on, and you will be just watching my back. Boop. It's not. What is going on? This is not even focusing. Now it's focusing. Okay. I need my soldering station. That would be that one. That one is good. All right. Another bug. That's some background music for you. That's Monty Python intermission. Okay. Ouch! The wire is getting hot. Enameled wires. Need to get rid of the protective coating first before I solder them on. So I have my iron to 400. Oh, where's the fifth wire? I need 5. let's start with these first. Oh, wire I took is too thick. Okay, let me. Yeah, I'll have to attach it. To the trays because I need some clearance. Okay. It's not sticking very well. Thank you. I guess this will be good enough for debugging. I hope I don't short anything. Hello. Who's there? Okay. It's very delicate. I'm not sure if it will probably break instantly. And I try to attach a probe. Now I need a grounding wire. Yeah, this one will fall off. I feel it already. try to attach to the via instead. Nah. That's stupid. I should have taken like super thin wires again. Now I'm stuck with this stupid thick wire. Don't I have like, I have so many. This is my assortment of, yeah, here it is. So the thin ones. The hair thin ones. I think I will detach the thick ones because they will, it's no good. Don't like it. Yeah. Sorry, it will take a minute longer. Oh, that's way better. I need the scissors. Every test point is lowering the signal integrity. I rather botch around and debug like that, because that's something that I'm doing once. And the blades that I manufacture, then it will be all good, and that's just for measuring. I mean, it would be nice to have like oh, that's the wrong thing. Like a counterpart. PCI Express breakout. That would work as well. Yeah, but I'm not using differential pairs. This is like really bad. Okay, I mean, I agree. It's probably a good thing. I only have test points for my programming pins, not anything else. You are the expert. Okay, that was the fourth line. Now ground. I need to label all the lines. Wait, I don't need Mosey. Okay, maybe, but that doesn't make sense. No, Miso, because there is no chip on there. I will detach Miso as soon as I know which one it is. Okay. Or I can leave it. Okay, I need some swaps and some alcohol. Here is alcohol, and where are the swaps? Here is a swap. Let's clean it up a little. Don't want to put that nasty Mosey. Banana flavored. How do you know Persian? Wait. I can't see names right now. Oh, where is this girl? Oh, this wire is. I'll be right there, and then. Oh, you're Tommy. Okay. Of course you're Persian. You're from Iran. Oh. Tommy, I didn't know who I am talking to. So now that makes sense with your test points comment. You are really the expert. I can't see names when I'm hearing only TTS. You know, they are not. Transmitted or spelled or okay. Okay. Now I need to vent it here because toxic gases. Okay, peeps. This PCB got some blue hair. Here you go. 0.5 millimeter pin pitch. Whoop. And punk, yeah. Cyberpunk. Okay. Do I have a label maker? Where's my label maker? Because I want to attach labels to that thing. Here. Aha! That's funny. Look at that. The last thing that I was labeling was miso. Okay, let's print it out. Miso, let's do mosi. GND, C, okay, C, okay. Hä? Nein! CLK. Wait. Why do I have 5 wires? Oh, chip select. And ground. Oh, there was some hardware for you. No, you couldn't see it. All right, but I mean, it was almost some hardware hacking here. Come on, stupid label. Here already. Why you know peer? Okay, that's ground. That's the ground here. Okay, we have ground. I also need some tissue because there is still some gunk. Then we have chip select. And turn on the oscilloscope again. I can't even see which one is which. Oh man. I can't see. It's too tiny. My eyes are so bad. I need a magnifying glass. Where is it? Or I will take the camera. When I do manual focus at the well, let's see. No, that won't work. Okay. Here. No. Can't see. I go to the microscope again. Okay, that's chip select. Messed up the label. Anyways, Miso, Mosi, CRK. What is next? Clock. Okay, this is the clock. I mean, I could just measure it at this point. And oh. Okay, so what is next? No, we are not doing. That's Miso. Miso Mosi is the last one. No, we're not doing it. Oh, you know what's disappointing? My labels. These are disappointing because they suck. Yeah, me too. No, wait, no. I don't like that when that happens. Okay. All right. Look how I messed up. Messed up the label here. Okay, let's record that. So, and for whatever reason, I'm attaching this Miso to an blank PCB label. It will be always floating. Yeah, but we can, I don't know. Ta-da! Okay, we can plug it in. And now we can maybe attach, this doesn't feel healthy. Okay, I will take, let's take ground. This is ground. And here we have power, so that's a good idea. Where are my probe tips? Huh? Oh, this chaos here. At least the heat is dropping right now. I need also to attach this ground. NG scope client, no. That's like this interface, national, whatever. It's rising again. What are you calculating, my friend? You are calculating something. Running AI models at home. Okay, these are not the right tips. For these, there is a tip for. Oh really? At this time? Uh-oh. Okay, we have chip select here. No, that's MISO. Clock. Okay, let's take the clock pin. That's clock. Where is chip select? Mosey. Okay. Yeah, that sounds good. Not that bad. Okay, I hope not shorting anything. Let's see. Let's run it and see what we got if I shorted anything. No, okay. Everything's running. Now, whoop. Let's see what we got. Oh really? I will check it out. Oh! It stopped. I think the data was misaligned. Let's try again. Okay, let's see what happens. I do a single shot. Whoop. Okay. So this is the data. I need to serial. Where is it? Where's my serial button? Ah! Here. It's so weird. Okay. SPI signals. Clock is 1. Okay. Where's back? Mosey. Okay, so we have no Mosey. Okay, but we have data, and it looks like it's 6, 7 is here. So we have 1, 2, 3, 4. 1, 2, 3, 4. But there is more data coming in. It's like, what's going on? It's sending extra data. Hey? Is it set? Oh no, is the packet length 16 bytes? Okay. Yeah, debugging is always cool, but why is it SPI host? Yeah, we need to set this default as well because SPI packet size is 8. No. Huh? Host buffer count. Where is this used? This is never used. Okay. SPI host packet size. Oh. That's missing. And do we have client? Client packet size, yeah. Okay. Okay, let's start again. Single. Okay, let's start again with fixed packet size. Oop. Oh, that's a 0 packet. Or did I detach the probe? Bad connection? Yeah, that connection. Oh, it's the stupid thing. Now I need the right cap because this is not the right cap here for the probe. Okay. Oh, one more time. Whoop. Okay, packet size is right. Everything looks good. Starting symbol and 6-7. Yeah, I have a million things to check out. Currently, I want to check out why nothing is working, or okay, I will add a blade over here, so I'll be able to see if we receive anything. Maybe a few blades. Okay. Okay. So I tripped the breaker with my ultra cluster. I hope you can see me now. Yeah. So yeah, let's continue testing. But yeah, everything closed, of course. All my windows are shut down. There's my okay. And I have some nasty remote desktop app. There is the like. What is this thing here? There's some nasty pop-up on my screen. Okay. Let's see if that works. Yeah, that's off. But the cluster is running. Let me turn. I can't hear. Oh, there is data. There's data received. But it stopped working at some point. Huh. And here I was cursing in the Ministry of Communications. What? Yeah, chat. Okay, so what I need to do is to find out why I have this here on my desktop. Is this like a Trojan horse, like remote desktop? What? Turn that off. Cyberluni be like as a remote desktop? How do I find? Here. Silent. Look at that bastard. Where's this coming from? Who started it? Look at that. It starts like... What the fuck? Okay, here we go. Now it's gone. Yes, I just renamed the file. Where is this coming from? Look at that. It was created 4th of June. Was there like an update? Where is this coming from? Microsoft Corporation. Yeah, but oh, it is a remote desktop, but what the fuck is that? X11? What is X11? Windows 11? Fuck this shit. Not happening here. Remote desktop. Remote desktop my ass. Alright. I can't, however, I can't turn on and off the Ultra cluster, it seems, because it might trigger the micro bloat from Microsoft. Unix GUI desktop. Oh! Yeah, there might be like the capacitors of the power supply might be like heavy load. The interesting part is when it was turned on and I tried to close the breaker again, it tripped instantly. So it was, I don't know, maybe there was like a protection, or how do you call it? This crowbar. No, what's the circuit called that shorts basically the input? Yeah, it was weird. Okay. I wanted to see a transmission, but the MCUs got in a weird state again. I hope I can reset them. Here we go. Crowbar. Okay, can I connect to the chat again? Can I connect this chat again? Oh, my home assistant probably died as well. Yeah. That needs to everything died. Okay. I need my TTS. Yeah, that's not coming. The port is in use. Damn. Okay, no TTS anymore today. Sorry. I need to read then. Upgrade, cancel. Yeah, I'm not upgrading that. I need to, let's debug. Maybe we can break it. So it breaks. Okay, we were able to break it. Let's stop it. Oh. Okay. Single. Let's start the animation again. Okay, we received data and then it stopped again. So here it is. Oops. I was recording. Okay. There we go. This is, yeah, that's a correct packet. But why did it stop? It's broken again because it's not receiving anything and it only received a partial transmission here. So I'm confused where it's locked up. Maybe if we debug it, we can find out what's going on. Handle reset. Okay. No, it's not doing that anymore. Okay. We actually don't want any breakpoints. There aren't any. Okay. Oh, we received more data, but where is it? RX complete. It's waiting for that. Okay, or let's do that. Or what's that CS line? Let's just check. B was it 12? That's 1, 12. Or we can just take the same GPIO pin 12 is here. Yeah. Or GPIO 12 is greater than 0. Let's try that. If we, for some reason, okay, we are receiving data. Okay, we are now, whenever there is like an incomplete packet or whatever, it seems we are receiving and transmitting data. We are doing it very slow fashion though. So, not much showing on there. Let's try prescaler of 4. That's not working anymore. Oh, it is. But now I can't really see data flowing here. Not sure if the pixels are in a weird state, but usually they shouldn't be. The data transmitted looks also right. Oh, wait a second. We get like only very occasional packets. Look at that. Oh, wait. We get 4 packets at once. Then a large gap. Why are the packets sent to the same address continuously? Are those the same packets? No, they aren't. It's a different address though. Oh no, okay. Let me stop that. I should send them to a different, not different row. The SPI lines are shared on this. Yeah, you're right. Yeah, you're right. That's all good. But then why is there like a huge gap in between? There is a lot going on, it seems. And the gap might be because it's switching the MCU, but no, it doesn't look like this is right. Oh, it might be switching between the, we have like two MCUs on the bottom, that there is like, it's alternating, but then it loses some packets. So let's see the data here. We have 10, 10, 12, 40, 50, 70. I think I like to try a different addressing method. Let me try different addressing in the thing here to alternate we also might be, because of the chip select that we removed, we might also lose packets on the lower, on the higher levels. Okay, wait, Julia sets min. Switch case to yeah, this is no, it's switching L3. That's correct. So there is actually a packet in between that we can see in this gap. This is done correctly, but then we lose different packets. I'm wondering if we can fix that. Fix that with proper chip select delay or something. Oh, this fly in here. Ah, this is so annoying. Okay, forget it. Okay, let me try one more thing. that will be L4. Otherwise I need like really to debug from, oops, no, wrong. CS doesn't have delay. We disabled it here. I'm wondering if that might be an issue. It might be too fast, but I'm not sure really. Or we are not processing it fast enough. That could be also the issue. Wait a second. Let me... If we are not processing the packets fast enough, that could be the same issue. Okay, so what we can do is we can try to optimize now this code. If we send with same speed and we still like using copying the buffers, which is bad, but let's switch to O2 again and upload that code and see what we get if we... Yeah, that's not... It's not doing anything. Okay. It's not doing anything. We restart. Nope. Oh, really? Did that break it? O0. No, it didn't. Okay, let me check that. And we are connected to the right one. Start. That doesn't do anything. The issue is I don't want to turn it on and off again, because then it might happen again. Next time I will use, connected, okay. Okay. I don't want a debugger. Ah, here's some data for you. Okay. It's broken again. Oh, this is so annoying. Was it prescaler A? Switch on secondary. Okay. It's not doing anything. Peeps, I'm ready to give up now. It's 1:30. I'm not seeing that. I mean, I need to slow down everything, send a packet and see when it's 3 a.m. there. Yeah. Alright, Tommy. Thank you for joining today, everyone. Good night, Sonic. Good night, Tommy. Good night, Johnny, and everyone. I'll be streaming next Tuesday instead of Wednesday because apparently I'm not at home on Wednesday, and then I hope I will have time to figure out the issues and finally do something useful, because that's the last stream before the Maker Faire, and at the Maker Faire I want to present something like running code and maybe VGA and whatnot. So we need to hack some hardware next time. I will be preparing everything. Alright, bye bye everyone, have a good night.